Okay, so we are in example 3. So we just did a couple examples. Maybe you took a break. Just a quick review here of what's happening. This is a topic called related rates. Okay, so this is basically rates of change, which you know is the derivative, right, with respect to time. Okay. And on the AP exam, if they give you guys a question like this, it could show up in multiple choice. It could show up as an FRQ. You're looking for damage control. You're just looking to get some points, and you'll find points by just interpreting what they give you. Okay. And so this is the third example. So let's kind of keep our strategy the same here. It says the top of a 13-foot ladder is sliding down a vertical wall. So here's your ladder. It's sliding down. And so as this tip falls down, it's going to be here, right? This base moves out. So as this falls down, the ladder is more like that, right? The length of the ladder never changes. It's still 13 feet, right? Your ladder's like this. And then as you slide down, both this tip is coming down the wall and that base of the ladder is going that way, okay? And it's sliding down at a rate of 1 foot per minute. So you're supposed to translate the top. That's what we're going to translate. So if this is sliding down, y, the distance between the ground and the ladder tip, is changing. So dy dt is equal to 1. Okay. Then it says, what is the rate of change of the distance between the bottom of the ladder and the wall when the top of the ladder is 12 feet from the ground? So let's do the first part. What is the rate? So we are supposed to find the distance between the bottom of the ladder and the wall. There's the bottom of the ladder. There's the wall. That's x. So find, it's a rate. So you're looking for dx dt, right? Find the rate of change of x with respect to time when the ladder is 12 feet from the ground. When the ladder is 12 feet from the ground means when x is equal to 12. Okay. All right. You would get FRQ points for interpreting that. You now know you're supposed to find dx dt, okay, when x is 12. Well, this is where you start. When you write down what you're trying to find, you need an equation with x, and then d dt it. Okay, that's our strategy. So once again, we have a triangle. Okay, your equation is going to be the Pythagorean theorem. How can we relate x, y, and 13? You would simply say, well, x squared plus y squared must be equal to 13. So if you're looking for dx dt, look back at your picture, right? And think about geometry, things that you know with triangles. You know sine, cosine, tangent, but we weren't giving any angles here, so that didn't make sense. But you've got the Pythagorean theorem, which is pretty straightforward. And when you take the derivative with respect to time, you get 2x. X doesn't match t, so dx dt, plus 2y. Y doesn't match t, so dy dt. And the derivative of 13, I'm sorry, this should be squared. The derivative of 13 or 13 squared is going to be 0. Okay. And so I need dx dt. Okay, that's what I'm looking for. So I can find that if I have all my other unknowns. I have x, it's 12. It told it to me. And I have dy dt, it's 1. Okay, but I don't have y. Well, just like in the last example, you guys have a right triangle where the ladder is 13. When x is 12, can you find y? Okay, you might remember your Pythagorean triple here. If not, you just have to do the work. Y squared plus 12 squared equals 13 squared. So that's 144 and 169. And if you subtract, you get 25. And so you get y is 5. But again, you might have memorized 5, 12, 13. The two most common triples are 3, 4, 5 and 5, 12, 13. Okay. All right. So now we can go fill in all our stuff and answer the question. So there's the 2. So that's 2. When x is 12, find dx dt. That's 2. We now know y is 5 at the same time when x is 12. And dy dt is 1. And so this is 10. If I subtract it from the other side, it becomes negative, and divide by 24, and that would give me dx dt. And that reduces to negative 5/12. Okay. All right, so this is the first time we kind of ended up with a negative. And so let's talk about that. I didn't throw it in there in this example because I feel like it's already complicated enough. But back up here, okay, when we were doing this, do you guys see how the rate of change of y is actually shrinking? It's going down. So in these related rate problems, oftentimes you want to put the sign value. So since this was going down, we would have said that dy dt was negative. And if you would have done that, what that's going to do down here is that would have been -1. And when you moved it over, that would have been positive. And then we would have gotten a positive answer for dx dt, which would make more sense, right? Because x, as this ladder falls, right? So say it's down here now, x is growing. It's getting bigger. Okay, so that's why this is a positive value, and this guy here is a negative value. Going back to our first example, if they would have told us that the volume, rate of change of the volume was negative, right? That would be a balloon that's being deflated. So we would have put a negative there. Okay, on this boat problem, technically, right, we said dl dt is 2. It's shrinking, right? So technically this would have been negative. Okay, and how would that change our answer? Well, down here, when we plugged in dl dt, we would have made that a -2, giving me -20 over 8, or -5/2. And that would make sense because, look, we found dx dt, same thing. Isn't x shrinking here? So dx dt would be negative. Okay, so now that we've kind of done the guts of it, adding a positive or a negative hopefully doesn't make it more difficult. I just didn't want to introduce them all at the same time. Okay, last example, and then we will clearly chat about this tomorrow when we Zoom. We've got the radius of a circle is increasing at a constant rate of 2. Right there. Translating that is the big game on related rates. The radius is increasing at a rate. So dr dt increasing, so positive, of 0.2. Okay. Then it says, what is the rate of increase of the area? So find the rate of increase of the area is dA dt when circumference is 20 pi. C equals 20 pi. Okay. So translate. You're taking English, you're translating it into a mathematical statement here. Okay. So where do we start? You start where you wrote find. If you want to find dA dt, you better come up with an equation with A and then take the derivative with respect to time. We're talking about circles. Everyone knows the area of a circle is pi r squared. So I've got my equation with A in it. Now I need dt. And so I better say, well, the derivative of A is 1, but A doesn't match t. So dA dt, that's the implicit part. Power rule derivative, bring the 2 down, 2 pi r to 1 smaller, times the derivative of r with respect to time because r doesn't match t. Okay? And at this point, look, I want this. So I can get that if I know r and dr dt. This is an actual multiple choice question from years back. And it's kind of clever, right? Do you guys know that circumference is just 2 pi r? So right there can go right there. And so you could plug in and say, well, dA dt is equal to 20 pi. dr dt was 0.2. And so you'd get 4 pi as your answer. Now, if you didn't see that trick there, right, if that wasn't obvious to you, which it might not be, that's fine. You still could find, you knew you couldn't answer this until you knew r. So you could have come up here and said, well, circumference is 2 pi r. And so if I set that equal, then I can solve for r by dividing by 2 pi, which tells me r is 10. And then you would have came back here and plugged in 10, and you would have got 20 pi. And then maybe you would have been like, whoops, that was obvious, right? Because I wrote it right there. Okay. So again, when you struggle with this, because I think most students do at the beginning, okay, it does get easier the more we do it. But when you're struggling, it's important to identify where you're getting lost. And more often than not, students are lost because they don't even know where to start. And if you don't know where to start, you're not doing this part of the problem, which is translating what they give you, writing down what you're trying to find, and that's the interpretation part. Because if you know what you're trying to find, then you find an equation with a in it that gives you a starting point, right? And then you know you have to take the derivative with respect to t because this is related rates. All right, you guys, happy Monday. Welcome back. Give the homework a go, right? Obviously, do the parts of the homework that you can, right? Don't just hopefully don't come to the Zoom tomorrow and just say, I couldn't do anything. I think that there's probably little pieces here and there that you could hopefully start with. Okay, take care.